Why does the atom release energy in the form of radiation after the photoionization process? What is the significance of the OK-Lel spectral peak, and why is it referred to as the Aushar line? What do the letters K and L represent in the OK-Lel notation, and how do they relate to the electron layers involved in the process? How are satellite lines formed in XPS, and what causes these fluorescent X-rays to appear in the spectrum? What is the energy loss curve in XPS, and how does it relate to the inelastic collisions of photoelectrons with the sample surface? Can Davis Zurins manufacture solid-state sodium-ion batteries made from seawater in Latvia? Why is the magnitude of the characteristic energy loss important, and what does it reveal about the nature of the sample? How do vibration excitation lines and vibration lines of electrons occur in XPS? What is the significance of the formation of vacancies in the inner shell layer of an atom during the photoelectric emission process? How does the atomic center potential change when valence shell layer electrons leap to higher energy levels, and how is this related to vibration excitation? What distinguishes vibration excitation from vibration separation of electrons in XPS? How does the movement of valence shell electrons to unbound continuous states lead to the creation of free electrons? What role do vibration excitation and vibration separation of electrons play in the overall XPS spectrum analysis, and how are they interpreted to understand the sample's properties? How can understanding these different types of characteristic curves improve the accuracy and depth of analysis in XPS material characterization? How can XPS full spectrum analysis be used to study the elemental composition of a material, and what role does it play in chemical power studies? What are the specific elements that might be present in the CO 0.85 say at our geocomposite, and how does XPS help identify these elements? How does the analysis of electron ionization layers for different elements provide insights into the valence and structure of those elements? What is the significance of performing peak splitting of the XPS pattern, and how does it reveal the coordination structure of different atoms? How does argon ion etching against particles help probe the composition and valence states of the material at various depths? What can be inferred from the gradual increase in divalent cobalt ions Co2+ and the decrease in trivalent cobalt ions Co3+ observed with increasing depth in the material? What does this gradual change in the cobalt ion content indicate about the material's surface, and what does it tell us about the oxidation of the material? How can XPS be used to study the relationship between the components of the solid electrolyte interphase SEI film formed on the surface of electrode materials, and how does the depth of the material affect this analysis?